If you've been keeping up with AI, you've seen it learn to write, to draw, even to code. But you know what? That was just the warm-up act. We're about to dive into the next massive leap, Agentic AI. And this isn't just about creating stuff anymore. It's about building an AI that can actually do things. Okay, just take a second and let that quote sink in. Bill Gates. He's not saying this is just another update. He's saying AI agents are going to completely revolutionize, totally upend the entire software industry. That's the kind of massive shift we're looking at here.
And that really is the big question, isn't it? We have AI that can chat with us, but how do you get from an AI that's just a passive conversation partner to one that's an active player in the world, an AI that can actually chase its own goals? How in the world do we make that jump?
So, let's get into it. What exactly is agentic AI that makes it a whole new wave? And how is it so different from the generative AI we've gotten so used to?
All right, here's the formal definition coming right out of the MasTech white paper. The keywords you got to lock onto are autonomy, goals, and adaptation. See, the AI we use now, it needs you to tell it exactly what to do. These new systems, they're proactive. They can come up with their own goals and then actually figure out the steps to achieve them.
So let's really break that difference down. It's a huge leap. Think about it. Moving from an AI that just processes our words to one that can actually operate in entire worlds, whether they're digital or even physical.
This right here, this chart lays it out perfectly. On the left, that's the AI we know and use today. It's what we call stateless, which basically means it forgets everything the second you end the conversation, and it just waits for you to give it a command. But on the right, that's the agent. It actively chases goals. It's stateful, meaning it remembers, it learns from what it does, and it makes its own calls. That, right there, is the game changer.
Okay, so we get what it is. But how does this thing actually work? Let's pop the hood and get into the real nuts and bolts, the framework that gives these agents a mind and the ability to act.
Before we get all technical, just think of it like this. You wouldn't build a skyscraper without a blueprint, right? Well, to build an AI that can actually think and do things, you need what's called a cognitive architecture. It's the master plan for its mind.
And that master plan, that blueprint, it has a name. It's called COALA. It stands for Cognitive Architectures for Language Agents. This framework says that for an agent to be truly capable, it's got to have three key things: memory, action, and decision-making. Let's make that super simple with an analogy. Think of these three pillars like they're parts of a person. Memory, well, that's the agent's brain. It's where all the information gets stored. The action space is like its body. It's everything the agent can physically or digitally do. And the decision cycle, that's its nervous system, processing everything and deciding what to do next. Okay, let's start with the brain. Memory. An agent can't learn a thing if it can't remember. So it needs two types of memory. First, a working memory, which is kind of like a scratch pad for whatever it's focused on right now. And second, a long-term memory, which is like a giant library where it stores all its experiences, facts, and skills forever. Next, we have the body, its action space. And this is a really important point. An agent's actions aren't just external things, like clicking a button or using a tool. It also has to have internal actions, the ability to think, to reason, to reflect on its own memories. So it's not just doing, it's thinking before it does. And finally, the nervous system. How does it actually choose what to do? That's the decision-making loop, and it's a very deliberate process. The agent thinks, okay, what are my options? Then it evaluates them. Which one gets me closer to my goal? It picks the best one, and then it acts. And then, the whole cycle starts over again. It's constantly thinking, observing, and acting.
So that's all the theory. It sounds pretty cool, right? But what does this actually look like in the real world? Let's see how this blueprint is already building some incredible agents.
And for this, I've got the perfect example. An agent called Voyager. It was built to play Minecraft, a game that has, no instruction manual and endless possibilities. It is the perfect showcase for how this co-allied framework actually comes to life.
Now, this is where it gets absolutely wild. Voyager gives itself goals like, go find some iron, and if it doesn't know how to do that, it literally writes its own computer code to create a new skill. And when that code works, it stores it in its memory. You know that long-term library we were talking about? This is so much more than following instructions. This is an AI that learns, adapts, and gets smarter all by itself.
And look, this isn't just about playing video games. These exact same ideas are already being used in huge industries.
We're talking about agents that help with medical diagnostics, that manage complex financial trades, that optimize entire factory supply chains. The real-world uses are already here, and they are growing like crazy. All right, so let's zoom out for a second. We've talked about the what and the how, but now let's talk about the so what. What is the real impact of this going to be, and what are the big questions we need to start asking?
Well, the numbers alone are pretty staggering. The market for agentic AI in business is projected to just explode, going from around $4 billion this year to over $182 billion by 2034. This is not some niche little tech. This is becoming a massive engine of the economy.
And here's what that actually means for our day-to-day lives. Right now, in 2024, basically 0% of our daily decisions at work are made by an AI. But by 2028, just a few years away, that's projected to be 15%. That is a breathtaking pace of change in how we work.
But of course, with all this incredible new power and autonomy, it comes with a whole new set of really serious challenges. We can't just build these things and then set them loose. We have to be incredibly careful about the consequences. Which means we absolutely have to build some guardrails. And these are the big questions everyone's asking. For example, who gets the blame when an agent messes up? How do we make sure these things are fair and don't learn our own biases? Can we even understand how they make their decisions? And maybe the scariest one, how do we stop them from being used for bad things?
And to bring it all together, this quote from Microsoft CEO Satya Nadella really paints the picture of the end goal. The vision here is a future where you're not juggling a dozen different apps on your phone. You just interact with one smart agent that knows what you need and goes and does it for you.
So, that leaves us with this final thought. This whole agentic AI thing, it's not a question of if it's going to be part of our world. The train has already left the station. The real questions we have to answer now are, how soon will it be everywhere? How deeply will it change our lives? And can we get those guardrails built in time?